Going to spend the next 3 minutes graphing a quadratic and intercept form. And here we have this quadratic that is an intercept form. It's pretty easy to do, I think. First thing we're going to do is we're going to solve for the intercept. So we take x plus 3 equals 0. Solving for x, we get x is equal to negative 3. So what do we know here? We know that when x is equal to negative 3, we get the point negative 3, 0. So it's a 0 of the function based on the zero product property. And if we do the same thing here, we have x plus 1 is equal to 0. If we solve algebraically, we get x is negative 1. That means we get the point negative 1, 0, which means as a function, this thing looks like this, I think. As a function, this thing looks like this. And we know that it's going to cross the x-axis in these two places. It's going to cross at negative 3, 0, and negative 1, 0. We also know this is a minimum parabola because that 2 is positive, so we know that the parabola is going to have a shape like this. The question is, where is that minimum value here? And the way we find it is actually really easy. We just do this. To find the coordinates of the... We just find the average distance between these 2 points. So we take negative 3 plus negative 1 divided by the 2 points is equal to negative 4 divided by 2, which is equal to oh, look what I did here. Can everybody see what I did? Somebody's watching going, got to know what he's doing. It's like, wow, that's really bad. So I can fix this, and I was going to start over, but you know what? This is how this happened, and I don't do all this work before I get to you intentionally, just so I can show you what it actually looks like. So if you don't mind, I'm going to fix this problem I had here. If I solve this, this would be at... Don't leave me. Just stay with me for one more second, because this is worth it. This is how this actually happens, so I'm kind of cool with this. We have x minus 1, right? When is x minus 1 equal to 0? When x is equal to 1. So we have that other point, that other intercept is over here at 1, 0. Golly, I don't know how to screw that up, and I apologize, but it's going to be all right. I'm sure of it. Now I am going to do that, and I'm going to find the average. What's the distance? Where is this middle point? I'm looking for where is this middle point between them, because... well, this is what I know. I can draw this without knowing what it is. This thing is going to do this. It's going to come down like this. Somewhere in here, it's going to get to its minimum. Well, not somewhere. Halfway between here and here, it's going to get to its minimum. And the question is, where is that minimum? But that's how I'm going to find it, because this distance right here, this is what I want to say to you. This is why this is definitely worth it. This distance right here is exactly the same as this distance right here. How do I know that? Because it's a parabola, and parabolas have symmetry. So we know if we fold this piece over on top of that one, we have a perfect crease here. So where is that thing? And how would you find out what's the average between the two? You take negative 3 plus 1 divided by 2, and you'd get negative 2 over 2, which is equal to negative 1. So this is the point right here, negative 1 something. So negative 1 what? I go back, we plug that in, and it turns out to be negative 1, a little bit of math, negative 8. And that's how we would do that. So that's how you graph that parabola. Hey, thanks for sticking with me through that. I think that this is a very, very doable process. What do we learn here? We're going to solve, we're going to take these two things, we're going to find out where does our function cross the x-axis. We're going to be we're going to be careful to write the equation correctly so we get the correct solution, right? It's terrible to do good math on a bad problem, and that's what I did. I got so hung up on rushing through it that I made an unforced error, and those can be avoided. So let's try to avoid those as much as possible. If you haven't already subscribed, please do, and your comments are always welcome. Thanks.